Good morning, children. Stay safely at home. So, I'm starting the next chapter, waves. What is waves? Everybody knows it is a disturbance which is created due to the vibration of the particles of the medium. Not only that, which propagates at once through the medium with the same speed. In a particular medium, the speed remain constant and the wave form, the form of the wave also it remains constant. That is known as the wave motion or the wave. And we know this also that if the wave we are considering, there are broadly two kind of wave, elastic wave and electromagnetic wave. Elastic wave, it is produced due to the property of elasticity and it is produced due to the vibration of the particles of the medium. Alright, and you know waves again you can broadly classify into two categories, longitudinal wave and transverse wave. Okay, and what are the longitudinal wave? When the particles, this is the particles of the medium, particles of the medium vibrate parallel to the direction of the propagation of wave. Means suppose the wave is moving in this direction and this is the particles of the medium vibrating to and fro parallel to the direction of propagation of wave motion, then it is the wave is known as the longitudinal wave. Alright. And if the particles of the medium vibrates, you see the particles of the medium vibrating up and down, whereas the wave is moving from west to east. Means the particle of the medium vibrates perpendicular to the direction of propagation of the wave, then that particular wave is known as the transverse wave. Alright, from this 9th standard you are studying this, so this is nothing new to you, everybody knows. In case of longitudinal wave, what happens? The particles vibrate, particles of the medium through which wave is propagating vibrate parallel to the direction of wave motion, but in case of transverse wave, particles of the medium they vibrate perpendicular to the direction of propagation of the wave motion. That is the basic difference. And we studied this also in 10th standard. When longitudinal wave propagates through a medium, then alternate compression and rarefaction region is produced. Compression region is which region? Where the particles come closer to each other, means the density increases apparently. And what is the rarefaction region? Where the particles move apart from each other, means density of that portion decreases apparently. That is known as the rarefaction. So when longitudinal wave propagates through a medium, alternate compression and rarefaction region is produced, and when a transverse wave propagates through a medium, then crest and trough are produced. I hope you can remember that this is the rarefaction and this is the compression, rarefaction like this for the longitudinal wave, and when transverse wave propagates, then this is crest and this is trough. Alternate crest and troughs are produced when a transverse wave propagates through a medium. Then next is coming, what are the characteristics of wave motion? One by one I will just tell. You can directly read it from the book because point wise nicely it is given in the book itself. Now what are the characteristics of wave motion? That also you studied in lower classes. You know that when a wave wants to propagate through a medium, the medium should have the property of elasticity and medium should have inertia. Then only a wave can propagate through the medium. Then second characteristics, when a wave propagates through the medium, then the wave propagates due to vibration of the particles of the medium. But remember that particles of the medium vibrate about their mean position to and fro. The particles never leave their position, never move from one place to another. But although particles do not move from one place to another, but the energy it get transferred from one place to another. That was the important point. I hope everybody can remember that point. Whenever a wave propagates through a medium, which quantity get transferred from one place to another? That is energy. There will be no medium transfer. There will be no material transfer. Okay, means the particles will be in their own position position and vibrate about their mean position, but they will transfer the energy from one place to another due to their vibration. And when the particles of the medium vibrating, then velocity of the particles at the different state of oscillation are different. What is the meaning? We just simple example I am giving. Simple harmonic motion you have studied. We have seen that when the particles vibrate in simple harmonic motion to and fro, then at the mean position velocity is maximum, and at the extreme position velocity is minimum. So like that, if you consider the particles of the medium, if it is at the mean position of its vibration, velocity will be maximum, and if it is at the extreme position of its vibration, velocity will be minimum, and in between the velocity will have the range, velocity will have the value greater than the minimum and less than the maximum. It is the meaning that velocity of the particles of the medium are different at different states of oscillation. Alright, now if you consider the phase of the particle, what is the meaning of the phase? That also I discussed in details in lower classes. What is the phase? Phase means the position, direction of propagation, direction of motion, not propagation, sorry, direction of motion of the particle at any instant of time, that is given by phase. Alright, now phase of the particle of the medium through which the wave is propagating continuously changes. Alright, and at a distance equal to wavelength, both the particles come into the same phase. Alright, or when the particles, the distance between the two particles are multiple of the wavelength, then the particles will have the same phase. Otherwise, the phase of the particles of the medium continuously changes. And when the medium, when the wave fall on the interface of two medium, means suppose that the wave was propagating through air, now the wave is falling in water. So on the interface it will be refracted. Refraction means it will enter in a different path in the second medium. Diffraction will occur, reflection will also occur. Reflection means what? Some part of the wave will go back to the first medium. You know, you have studied in 10th standard, when light falls in an interface, then what happens? Between the interface of two media, it gets partially reflected and partially refracted. The same thing happens for any kind of wave. And when a wave propagates through a medium, then it suffers three other phenomena also, that is interference, diffraction. Now interference and diffraction exhibited by all kind of wave, may be longitudinal or transverse, but transverse wave only exhibit polarization. The phenomena polarization is exhibited by the transverse wave. The last 3 points, what are the last 3 points? That when a wave fall in the interface of two media, it gets reflected and refracted. I have not written. Then next point, interference and diffraction. The wave exhibit interference and diffraction phenomena also. Then the third point, transverse wave, only transverse wave exhibit the phenomena of polarization. These 3 points I have not written. The rest of the point I have summarized in short. Okay. So what are the points? Medium should be elastic and have inertia through which wave is propagating. I have not written. Particles of the medium through which wave is propagating do not move from one place to another. Velocities of the particles through which the wave is moving are different in different state of oscillation. Phase of oscillation of successive particles continuously changes. Here one thing I have said but I have not written, that when the distance between the particles is equal to the wavelength or multiple of wavelength, then the particles will be in same phase. Then next is energy propagates from one place to other when a wave moves through a medium. And then next one is two or more waves can propagate through the medium without affecting the motion of each others. Alright. So these are all characteristics of wave motion. You must learn and practice it. Now the few terms associated with the wave motion. That also from the very lower classes you are studying it. First is the amplitude. What is the amplitude? The maximum displacement of the particles of the medium from its mean position during oscillation is known as the amplitude. Next is time period. What is time period? Time needed to complete one oscillation by the particles of the medium through which wave is propagating is known as the time period. Then what is frequency? Number of complete oscillations of the particles of the medium in 1 second or number of complete waves produced in 1 second is known as the frequency of the wave. And there is a nice relation between frequency and time period. Frequency is equal to 1 upon time period. Everybody knows it, that frequency is equal to 1 upon time period, and SI unit of frequency is hertz. H capital, Z small, according to the physicist, name of the physicist Hertz, Hertz. And then next one is phase. Phase of a particle of the medium is, phase represent the position of the particle and direction of motion of the particle at any instant of time. That is denoted, that is known as phase. Alright, the term which indicates the position of the particles of the medium and direction of motion of the particles of the medium at any instant of time is known as phase. Then next one is wavelength. What is wavelength? The distance travelled by the particles of the medium during one complete oscillation is known as wavelength. And we can define wavelength in 4 ways. This is the first definition of wavelength I said. Then the second definition of wavelength, generally we consider this definition in the higher classes, that is, it is the distance between two successive particles in same phase. What is wavelength? The distance between two successive particles in same phase is known as the wavelength. And in case of longitudinal wave, the third definition, the distance between two successive compression region or two successive rarefaction region is known as wavelength. And in case of transverse wave, the distance between two consecutive crests or two consecutive trough is known as the wavelength. So wavelength, generally it is denoted by the Greek letter lambda. Then what is wave velocity or wave speed, denoted by V? Wave speed is the distance travelled by a wave in 1 second is known as the wave speed or wave velocity. And we have derived this also, the relation between V and lambda t. How you can do it? If you consider lambda be the wavelength of the wave and t be the time period of the wave, then in t second the wave travel a distance will travels a distance of lambda. Is that clear? So in 1 second, how much excuse me, in 1 second how much will be the distance travelled? Lambda by t. Now distance travelled in 1 second is known as the velocity. So V is equal to lambda by t. Again 1 upon t is equal to n. So you can write V is equal to n into lambda. N is the frequency of the wave and lambda is the wavelength of the wave. So these are the few important terms related with the wave motion and their relations also. Now let us try to get equation for a progressive wave. From the name it is clear, progressive means the wave which can propagate through the medium. So consider this situation, that let us consider the wave is propagating along this direction and there are several particles here. There are the particles which are vibrating. Okay. Now, if you consider this point O as the source of the wave, origin of the wave, then you know that all the particles, they will have the simple harmonic motion. So, what will be the equation of motion for the particle at O, which is the origin? It will be simply y is equal to a sin omega t, because we know that all the particles, they are having the simple harmonic motion. So if you consider what is the equation of simple harmonic motion, y is equal to a sin omega t. Alright, so here what will be the equation of motion of the particle at the point O? It will be y is equal to a sin omega t. But all the particles may not be at the origin of the wave. So let us consider a particle P. Means we have considered the particle P here, which is vibrating like this. okay, or which is vibrating like this. Anyway, you may consider. So, if you consider the particle which is at a distance of x, what will happen? This particle will lag behind O. O will start vibrating first, then it will transmit its vibration to the next particle, it will transmit its vibration to the next particle, so on. This way the vibration will be transmitted and will come to P. Alright, so what will happen? P will lag behind O. O will start vibrating first, then P will start vibrating sometime later. And what will be the phase difference between P? How you can find out? Just consider this. If you consider that concept of the uniform circular motion and simple harmonic motion, then we have seen when a particle is moving through a circle, when it is coming back here, then it will be in same phase. Alright, so when it is completing one circle, then what is the angle it is making? It is making the angle 2 pi. Alright, and when it is coming to the same phase, means how much distance it is traveling? It is traveling a distance lambda. Alright, so this is the point you have to understand. When path difference is lambda, phase difference is 2 pi. This is the most important concept in physics. Always we apply this. When path difference between two particles is lambda, then what is the phase difference between the two particles? 2 pi. Because after completing one circle, it will come to the same phase. And the particle which are in same phase, successive particles, the minimum distance between two particles in same phase is known as the wavelength. That's why this is coming, that when path difference is lambda, phase difference is 2 pi. Now here you see what is the path difference between O and P? X. So if you do just the unitary method, when path difference is 1, phase difference is 2 pi by lambda, and when path difference is x, phase difference is 2 pi lambda into x. Alright, so what you can say? So you see, what will be the equation of motion for the particle at P? As I said, it is having a phase difference phi. So it will be omega t minus phi. What is this phi? Phi is the phase difference, and here we have got how much is the phase difference? 2 pi by lambda into x. Alright, so one can write it as 2 pi by lambda as a constant kx. Is that clear? So you can write what is the equation? A sine omega t minus kx. This is the equation for a progressive wave. Alright, remember what is the equation of a progressive wave? Equation of a progressive wave is given by A sine omega t minus kx. So you see, what is the equation of a progressive wave? It is A sine omega t minus kx. In this case, remember the wave is moving towards positive x-axis. Okay, positive x-axis. Then it is omega t minus kx. But if the wave moves in the opposite direction, then what will happen? Just see, if the wave moves in opposite direction, then P will vibrate first, then O will vibrate. So P will lead by phase of O. So in that case, what will be the equation of motion? It will be A sine omega t plus kx. So when it will be plus, when wave propagates or move along negative x-axis, then it will be y is equal to A sine omega t plus kx. Now there are certain other form of this, the same equation also. Now you see, this is the basic equation of a progressive wave. Y is equal to A sine omega t minus kx. Now you see, omega you can write it as 2 pi by t, and k is equal to 2 pi by lambda, all of we know. So you see, one can write y is equal to A sine 2 pi small t by big T, and here 2 pi x by lambda. So you can take 2 pi common. If you take 2 pi common, then equation become t by t minus x by lambda. So this is another way to write down the equation of the progressive wave. Alright, this is another way to write the equation of the progressive wave. Another way is that you see omega is equal to 2 pi by t, means it is 2 pi into n. Is that clear? And n is equal to v by lambda. Isn't it? N is how much? V by lambda. So you see, if you substitute that, what are you getting? A sine, it will be 2 pi v by lambda into t minus 2 pi lambda into x. So you can write it as 2 pi by lambda common vt minus x. So this is another form, another way to write down the equation of the progressive wave. So all these three forms you are supposed to remember. Most of the cases we use this. I always suggest, if you are unable to remember all the three, remember the basic one, a sine omega t minus kx. Alright, and also remember that negative sign will become positive when the wave will move along the negative x-axis. When the wave will move positive x-axis, this is negative, and when the wave will move along negative x-axis, then it will become positive. And omega has different form. Omega 1 can write 2 pi by t, omega 1 can write 2 pi n, omega 1 can write 2 pi v by lambda. So depending on the given numerical, given information in a particular numerical, you can change. So those who are unable to remember all the three, my suggestion is that remember the basic one, that what is the equation of a progressive wave. It is given by a sine omega t minus kx. K is having only one expression, that is 2 pi by lambda, but omega, depending on the informations given, you can write it in different form, and by taking the common terms out, you are having this relation that y is equal to a sine 2 pi within bracket t by big T minus x by lambda. Big T is the time period, and one can write this also, y is equal to a sine 2 pi by lambda vt minus x. In some cases we prefer this third one also. Alright, so these are all the equations or different forms of the equation of a progressive wave. Thank you, children.